Okay, I hope I haven't screwed anything up. I'm having trouble with my computer, and I get nervous for the videos anyway. But this is a video about debt sizing when you have a different wind probability and the importance of P99 or P90 and so forth in debt sizing. So I've worked quite a bit on this stupid little page on the website. I put a normal kind of introduction, and then I think I have some PowerPoint slides on the wind, and I began by putting my favorite little graph. This is almost my favorite graph in the world, I think. It shows the P50 at the top, and then the P90. That's supposed to happen once in 10 years, and that the actual, which is lower than the P90. And then we have another graph from Garat Hassan who says, "Oh my God, here are the actual distributions. Here's what it should be. These should have been moved over here, so we're off by a pretty big percentage." They claimed that was mainly due to transmission problems. So I'm trying to explain in this website, and I'm trying to explain in my video right now, that if you have a P99, it's not some statistical crap that you don't have to worry about. It's not some downside case. It can affect the debt sizing and it can affect the tariffs you charge, and it's a very important kind of number. So I go through and say, well, if the DSCR is 1.35 for a P50 and it's only one time for a P99, you can, if the P99 case is more than 25%, which is DSCR minus 1, below the P50 case, then the P99 case will become instrumental. You can do a couple of little, I get confused by all this dividing stuff. I'm sorry, I do. I'm admitting it. But if you take 1 divided by 1.35, that's the percent difference uh, between this cash flow in the P99 and the P50 case that will start, if the cash flow difference is more than or less than 0.74, then the P uh, 99 or the P90 case, whatever it is. So I said, okay, here's how you do it. You kind of take the P50 case and then you take the P90 case. Well, it's the P50 times the ratio of the P59. Now, this is, be careful, that's not necessarily production. This is cash flow. It only works if all costs are variable. And then what you can do is say, okay, the DSCR in the P99 case, and we divide it by the DSCR in the P50 case. So you take 1 divided by 1.35, that's our number up here, and you compare that to the ratio of the cash flow, and that determines which kind of debt sizing is in place. Now I put some of my favorite little quotes from term sheets. This says the DSCR in the financial model should be no less than 1.35 based on a P50, one time based on a P99, and then I have a bunch of other examples where I put P99, P50, P99, P50. They're all sorts of different things, and I didn't put here that they're also debt to capital constraints. So that's a little supposed to be an introduction to show you that you have different DSCRs and they relate to for P50 and P90. Now, then I go through in this website, I'm not going to go through the whole thing. I try to explain that everything comes, my friend Pascal told me this, everything comes from the standard deviation. If you know the standard deviation and you know the P50, you can compute P90 in this case. This is so stupid. This should have been 0.1. Sorry, I gotta go fix that. So this is an example of some kind of wind analysis. They had a Vestas machine, and if you know here's the P50, which was excuse me, 125.3, that's right. And then the standard deviation for 1 year was 20.2. And you take that and you put 0.01, and then you get the P99. So sorry about the error here. I'll have to fix that. Okay, and then I go through some other examples and try to really discuss this 10-year versus 1 year P90, and I found this ancient history thing, this ancient history where they put the 1 year P90, 10-year P90, and please, the 10-year P90 is not, damn it, it's not taking an average of the history or any crap like that. Please, it's not that. It takes out the ups and downs. It takes the ups and downs out of a 1 year case. A 1 year P90, P95 is always the production. This is energy production. Here's the energy production in the P50 case, always the same. Okay, whether it's 1 year, whether it's 10 year, that's why these bankers, they're so stupid sometimes. That's what I was, but whatever. They say, this statement, 1.3, when using a P50 1 year, you don't have to say 1 year there. You don't have to say 1 year because the P50, whether you take a 1 year or 10 year, it's always the same. You see, here's the 10 year, here's the 1 year, here's whatever. Okay? Now, you can see that the 1 year and the 10 year is a smaller, or there's more of a downside in the 1 year than the 10 year because it includes all the variation. I'm going to go through a little example, and in a file you can download, I explained that. Now, here's what I'm really doing. And then I put some actual public wind studies on here, and where you can look at P90s and P50s and kind of go through it. I strongly suggest it. The big question is, how in heck did they come up with these standard deviations? And a lot of times, I'm sorry, I believe it's a lot of crap. Because they have to make standard deviations in things like cross synthesis, overall substation metering, wake. How do you get the standard deviations of all these? And these are the ones that really, really matter. Okay. Anemometers, apparently old history. Now they use the LiDAR, whatever. And then when you put all of these standard deviations together, I'm going to show you this in a minute. You can use, if they're independent from one another, a gigantic if, then you can use something called a mean squared error. And I haven't put this up, but I made a whole Monte Carlo simulation to prove to myself that this mean squared error works. Now, the subject, I'm sorry about this very, very long introduction, but the subject of this video is then, how can we size debt in a P50 or P90 or P99 case? And how can we make this process not a total nightmare? And how can we have to compute. I'm not even reading this stuff because I can't right now. But how do we use a P50 case and a P90 case and then take the debt sizing, which could be either P50 or P90, or to make even things more complicated, it could be a debt to capital case. So the debt to capital might be sized from any one of these three rules, and we have to pick the one that gives the lowest debt, because bankers are so conservative, in a good sense of being conservative. They like old things. They're careful, okay? And so I'm going to show you a simple example of this first, where we're just given P50 and P99. I'm going to go through a little bit of this. And then you come up with a debt size in a really simple case. And then I'm going to go to a little more complicated case where we have fixed cost and variable cost, which are really kind of an important issue in this whole debt sizing business. Okay? And then we'll have a summary page here. I put too many little screenshots here probably, and I've got to redo this a little bit. But here's our case. So let's see if I can explain this a little bit better. Now, the first thing I better do is I'm going to open generic macros. I'm so sad that nobody uses this. I try to show it in my classes, Control Alt C to get the stupid coloring right. So you don't waste all this, you don't waste so much time on coloring, okay? And let's put a conditional formatting in and get that all done, okay? All right, now, so we have the inputs. I wanted to color the inputs. That's just from column A, obviously. Now, the I'm assuming a cost of a project and then some cash flow available for debt service with a kind of base case thing. And then I assume, well, this is, I call it the P99. I should call it P99 divided by P50. How about 2 P50 divisor? Now that's very analogous to the DSCR, because when this, and I put a little spinner box around this even, when this is higher than this one, do you see right now, if you can see, I put a little conditional formatting, and when you do conditional formatting, I hope you listen to me occasionally and do this new rule, and then after you put a new rule, you've got to use a formula. So I just put a little formula to show which was the minimum. I'm not going to bother belaboring this. You can download this file, of course. Okay, so now if I make this, now this I should be a little more clear, sorry. So if I take the P50 case, I might have to write that. The P50 case divided by the divisor equal the P99 case. Or P99 case. And that's how we're going to define this case over here. And I realize I did something really stupid just now. I took off some of the I was going to have, I had little yellow tabs that showed what calculations you should do. I have another file on the website that you can do that. So if we take this one divided by the P50 case, we get this one. So the ratio of the P90 divided by the P50 is 71%. Now, I'm going to give you the result kind of quickly here. 1 divided by this is our 71%. So P99 divided by P50, I'll put an equal, and then that's 1 divided by this number. Now, when a DSCR in P50, now this is assuming a P99 as a one-time DSCR, and I didn't spell when right, did I? P99, P50, when DSCR in P50 is bigger than P50 divided by P99 divisor, use P50. Okay. Sorry about kind of the thing. So if I make this less, oh, I did it by 10. Then you use the P50 as the constraint. That yes, the P50 gives you a lower debt than the P99. When this is greater than, I'm going to put 134. It's still P50. I'm going to put 135. It'll get confused. Then they're the same. 136. It's just when this is when you can compare this ratio of the cash flow. Now, I'm just going to go through a little kind of calculations to do that. So you could also compare this number to, in this case, up to, and we'll put this number divide, which is not necessarily equal to 1, of course, divided by this number. In fact, just to digress for just a minute. Oh, I should tell you this. In this file, tried to make a new kind of cool little thing where I point you to all the websites. And my website, of course, I'm promoting my free website. I don't know why. Um, I hope, and I might not have done this. Oh, I didn't put all my little uh, uh, comparisons of different ways people compare the P50 and P90. Oh, maybe I'll get in trouble by giving you that. Maybe that's why. And what I mean by this is this was just an excerpt from it. Okay, this was just a little excerpt where I have a whole bunch of different examples. They used 1.4, not 1.5. They used a changing DSC. Oh my God. 1.4, 1.0. But sometimes people use P90 instead of P50. I guess I didn't show that. Okay, so what? All right, now if we go through here, we can then get the outlays, and then I said, okay, what happens if we increase the cost? We could increase the cost by allocating the chairman's salary or something to our cost. And the reason I said that is our first kind of debt sizing. This is a little bit bad. I think I should have put the criteria. Our first debt sizing is to take the total project cost and multiply it by the ratio of project debt to project cost. Now, if that gives you a lower number of debt than all the rest of them, then that's going to be in place. So if we put 50% here, then that's the constraint. And my reason for going on and on about this is if you put extra costs up here, if you start putting a whole bunch of extra costs up here, well, then you can kind of easily eliminate this constraint. And then I said, okay, well, let's compute the P50 debt service. And I said, I hope, in this case, I was really kind of simplistic. I said, well, let's just put a debt repayment switch up here. It's right up at the top. What in the heck is going on? I need to. Oh, Jesus. Stupid advertisements. Now it's going to waste a half an hour or an hour to get rid of that stupid stuff. Probably other people can do it more quickly. So I said, take the cash flow in the P50 case. Now here's a big lesson. When you're going to do this P50 and P90, unlike I say, if you have a bunch of scenarios, don't pollute your inputs with these scenarios. Stick all the scenarios in a different page. Most people do that, but it's a very good practice because I didn't. I used to put, we have 3 cases of interest rates that change. Okay, so that's the first thing we do. So I multiplied that. This is a calculation. Obviously, I should say DSCR equals CFADS divided by debt service, or debt service equals CFADS divided by DSCR. Okay, and that's our first one. So we do that, and I think I didn't finish what I was just going to say, which is you do that both for the P50 case and any other case that could constrain your debt. And in this case, it's the P99 case. Okay, now let's. Then I said, okay, the second key formula is that debt size equal NPV of DS. And that debt size, I should say really at COD, but I'm going to not say it. And the way you can get this, here's what I purposely did. I made the interest rates change a little bit. And then you cannot use the NPV formula, and you cannot use this formula that says 1 divided by the interest rate in the current period. You have to put a memory of this thing in. I don't know if I'm horrible at kind of explaining this now. This is a horrible thing here. This one should be over here. I violated one of these rules, and I'm sorry about digressing here, but I want to really emphasize that when there are some rules that you should follow. I call them criminals. I say here, this is no hard coded numbers, duh. And don't make the formulas all the way the same across the column. So I put these. There's a really nice lady who let me teach a class who said, go through these rules, these criminal behaviors. Don't make it a best practice kind of crap, but make sure people don't violate these rules, which I just violated. Now, what I do here, what's this one? Oh, excuse me. Okay. I said, okay, let's take the, oh, shoot, just a minute. Okay, let's just compute a little compound factor. And if you've seen other videos, you almost always put a little, you know, multiplication by a switch here, or a flag or a mask or whatever in the hell you want to call it. And then you can put a sum product. Now, obviously, I must have done this before with the NPV and had a flat rate, but I said, no, let's do this. So you can put equal sum product. And basically, whenever you divide something in a project finance model, you should use this divide in the sum product. So that's how we compute the debt service. And then here's what we do. We prove that it really works. And to prove it really works, you put this, where's the opening balance? Another mistake. I inserted this thing where I shouldn't have. This is that number, and you make the opening balance equal to the closing balance. Now you have the debt service, and then you compute the interest rate, the interest cost, rather, the interest expense after COD. And then you say, well, here's our formula. ds equal I plus P, so P equal ds minus I. I think that's okay. You use, that kind of looks a little funny. Okay, you use a little algebra. You don't force things ever. Try to not. I didn't say ever. Now, I can look up and I can see, let's use a lookup. And I have noticed I've lookup interpolated here. But we're going to look up on this number for the whole thing and then look up on the closing balance. And that should equal just about 0. And you can even put a round in there. And, you should put some kind of audit things in your model. And that we probably didn't need. We could have probably used more decimal places, but that's okay. And don't overdo it by your stupid little which I did. Okay, I did it too. Oh, I'm so fancy with 100 different audits. Good, fine, okay. But this is the big one. This one on the balance sheet. And then you do exactly the same thing. Oops, I have a little thing here. I suppose I should put a round of this one, or how about 3 equals 0? Let's be inconsistent, because it's boring to be too consistent. All right, and then you did exactly the same thing where you put this was what I did. Okay, this is the P99 debt service. Exactly the same thing, except you start with the CFADS in the P99 case. Okay, and then you get this debt. So in this case, in the amount of debt in P99 was lower than P50, And both of these were lower than this one. Perhaps I should have, it wouldn't have hurt to move this one out here. So we have three kind of cases. And then I can't remember. Oh, I put the here and then did our little conditional formatting. And remember, the big theme was if you would make it a smaller difference between P50 and P99, you get the P50 takes it. But if the P99 versus the P50 is really big, then the P99 case it kicks in, and that can give you a lot lower amount of debt. So this coming up with what's in the P99 is a big issue. Now, that was a little bit of an introduction and pretty simple, and I'm going to stop this video because I get really nervous when the videos start to get too long. So I'm going to make a second video right now, right this minute. I'm going to make a second video where I'm going to go through a little more issues on how you get this. And in this one, it's called the intermediate model. We're going to put some fixed and variable costs in, and we're going to look at some kind of a hypothetical wind study. This is not for any real project. Don't think I did anything bad by, giving any crap. So that's the next video. So that's the end of this one.